Generally, students found it pretty accessible, which was great, and teachers as well. But it was a new study design last year, 2024. It was quite a lot of new content that was examined, and some students found that really challenging. Question 4 in short answer, part A, asked for an expression for an equilibrium constant, Kp. Now, that had never appeared in prior exams before. Talking to Vika, it was because the study design talked about capital K as being an equilibrium constant, whereas in previous study designs, it was K subscript little c. But that was a surprise to most teachers that I've spoken to, that question. Vika consequently compensated that when they marked that question, and that's reflected in the examiner's report. Another area that's a bit contentious is theoretical enthalpy change. The new study design has a new data book, and the new data book has tables, items 9 and 10, that are, or 10 and 11, that are average bond enthalpy values. Having taught IB, I was familiar with how those values are used, but they were new to VCE. And the sample exam that came out mid last year had a question that required calculation of enthalpy change, which is most teachers would think is beyond the scope of the study design. And that's one of the other areas that, and that question wasn't particularly well done. In fact, very few students performed well on that question. And that's because it was new to the study design. So there were a few areas that tripped students up. They were stoichiometry, where there was not a 1-to-1 mole ratio. There was balancing redox equations in alkaline conditions, which is a new inclusion in the study design. That's clearly in the study design. The technique that I always teach is Kohnes, Kohnes. It's similar to balancing a redox equation in acidic conditions, but then we put the N in for neutralization. So after balancing hydrogen ions, we then add hydroxide ions to both sides of the equation to make the environment alkaline. Anything to do with alkaline half equations wasn't well done. There was also, and it's clearly stated in the study design, that with NMR, high resolution NMR, proton NMR, there are integration curves, and that's clearly stated in the study design. And there was a question that asked the relevance and the importance and the significance of integration curves, and that wasn't well done either. So I guess one of the take-homes is use the study design as a checklist and make sure that you've covered off every single key knowledge dot point and key science dot point in preparation for SACs and exams. So that they were some that tricked students. The easy marks, I think, were...
It's always good to talk about.
Always questions to do with sustainability. And one thing Vika has done is they've put in the data book, at the end of the data book, they've put in the diagrams for linear and circular economy and the United Nations Sustainability Development Goals and the principles of green chemistry. Not all of them are relevant to chemistry, but where they are relevant, they're in the data book. So some easy questions that most students could access were trying to work out where a chemistry principle applied to one of these sustainability or green chemistry principles. So those students who have done Unit 1 and 2 chemistry, you'll be already familiar with looking at sustainability. It's interesting that there were 2 out of the 30 questions that were deemed by VCA to be invalid. It didn't matter whether students chose A, B, C or D or didn't answer the question, they were awarded a mark. And one thing I would take that is keep an eye on time when you're doing the exam. Don't get fixated on a question that you're unfamiliar with, because it would be very easy to spend more than a minute on a question that is nonsensical, that can't be answered, and be very easy to spend 10 minutes of the exam fixated on something when the best thing is to move on. And if there's enough time in the exam, come back and have a look at a question like that. But for 2 out of the 30 questions to be invalid, means that sometimes the exam panel makes mistakes when they're setting questions. So if a student thinks there's something a bit unusual about that, move on. So another exam strategy is always with multiple choice. If you're not sure of the answer, eliminate maybe 2 distractors and always have a guess. Always have a guess. Yeah, so don't leave any question unanswered. In a way, I think the trend in chemistry over the last study design has been towards more key science skills. And there's been, certainly in the last study design, there's always been a question, normally the last question or second last question, that is based on scientific thinking and skills and application to a sort of a new environment. So it's important when studying for chemistry that you don't just make sure you've ticked off the key knowledge dot points, but also those key science skills, defining variables, using the study design, which clearly defines some of the terminology like accuracy, precision, validity, resolution, reproducibility, repeatability. Those sorts of questions are coming up more. With the new data book in the new study design, VCA have taken some of that requirement to memorise off students. So, for example, students don't need to remember the charges on polyatomic ions or solubility rules anymore. That's provided. And like I mentioned before with sustainability, the principles are all listed, but there still is some memory work required, particularly in Unit 4, with organic chemistry, the organic chemistry reaction pathways. So my advice to students is when you get to that part of the course, make yourself a map on A3 and put it on the bathroom door and teach people at home the reaction pathways, because there is a bit of memory work there. But there certainly seems to be a trend into getting students to apply their knowledge beyond a situation which that they're more familiar with.
Let's talk now about part B of the exam, the
Okay.
short answer question, and what you kind of take away from the examiner's report on that section is.
I think the easiest question was 3A. That was a simple nutrition information panel. So that required that students could work out where in the data book to get the information that protein is 17 kilojoules per gram, carbohydrate 16 kilojoules per gram, and fat 37 kilojoules per gram. And then it was a very straightforward calculation to calculate the energy. And in this case, it was a bread, but you can predict that there'll be a similar question on the exam at the end of this year. It's a clear study design key knowledge dot point. And that sort of question has been on previous exams, predictably over the last study design as well as this study design. So that was a very achievable sort of question. I guess the hardest question, I think, was question 8, part B, part 4, which was to compare the resolution of data in 2 methods. It was out of 2 marks. The first mark was relatively easy to get, but very few students got 2 out of 2 for that. And I think it comes back to students and teachers not being familiar with some of the new inclusions in the study design. That's something to look out for. I think the trickiest question in part B was question 3C, part 3, and that was the theoretical bond enthalpy question. It required using numerical data or quantitative data, but you didn't need to refer to the actual numbers. So in other words, it was a qualitative interpretation of numerical data, which was very novel. That sort of approach hadn't been seen before. So I suggest that we're waiting for VCA to clarify with the frequently answered questions how similar questions will be approached in the future and how that actually fits in with the study design. But that was a surprise, and that most students found that very challenging.
You've been an examiner in the past, Louise. What is, you're not currently, but to put your kind of mind into the space of what the examiners were doing, like what's the goal, do you think, of creating a question like that? Is it to try to separate the really top students, or is that a case of where it just hasn't quite landed properly? Or
Yeah, there certainly is the intention, from my understanding, talking to VCA, with setting assessments, whether they're SACs or they're exams, about 25% of the paper should be accessible to most people who sit the exam. Another 50% should be doable by the cohort. The final 25% is really to separate students so that they can get a study score anywhere from 50 down to the 50s and then down. So there are certain questions that can distinguish highly capable students and actually help rank them. It could be argued that this is one of those questions that is a discriminator. So there will always be questions in any exam or any SAC that is designed to separate maybe the top few students. General students shouldn't be concerned about that. Hopefully, most of the paper should be accessible. And that comes down to exam technique too. I always recommend to my students, don't start the exam or the SAC. Don't start at question 1 and go through chronologically. I would actually work out how many marks is the assessment worth, and how many minutes do you have? And if you've got reading time, which you do in the exam, use that time to find your favourite question. Because if you find your favourite question, it gets you relaxed. You're confident. You start earning marks. You're thinking, oh, yes, I can do this. And you can actually save time as well. So if you actually say, maybe question 3, it's worth 6 marks. I'm going to spend 7 minutes on it. And what I used to do when I was doing uni exams, I would write times on my paper. And I wouldn't start with question 1. I might start with question 3B, but I would write down the time that I would have and I would get those marks. It's just one way of doing it. It's not necessarily the right way of doing it, but it's one way of approaching it. If you actually do the questions in order that you're most confident with them, then you're going to have time at the end to answer the questions that are tricky. There will always be tricky questions because the examiners are trying to discriminate and rank students. But hopefully you're not bogged down on a question that might be excluded, like one of the multiple choice questions that was deemed invalid, or a question where very few students got marks. You're better off working where you can get marks and earning the runs on the board. One thing that we did at Edrolo, we made a whole lot of lessons on key science skills. I would encourage teachers and students to look at those key science skills. They're broken down into a number of bite-sized chunks, and to use those and think about the key science skills to go along with any key knowledge area that you're considering. And for students who are studying other sciences like biology, psychology or physics, the key science skills are across the board for VCE sciences. So if you're doing more than one science, practicing the skills will help you with your other subjects and vice versa with chemistry. But always try and think about applying the key science skills to your chemistry content.
What's a key science skill that students most often struggle with? Is there one that you've seen over time that seems to be
There's a
really
number.
hard?
I was surprised on the exam last year. So question 8C part 1 was a question about the independent variable. Now, this is something that as science teachers, we start teaching in year 7. And it's basically the variable that's changed on purpose in an investigation. And I was surprised that only 69% of students got that mark, which tells me that they're confused about definitions. Maybe they're confusing independent variable with dependent variable. And this would be something that as teachers, I would be introducing into every demonstration, every prac class, ask the students, which is the independent variable, which is the dependent variable. So this language becomes understood, because to me, they should be easy marks to get.